In this lesson, I'm going to show you how to determine the x and y components of vectors a and c, how to add the two vectors, and how to subtract one vector from the other. Let's begin with vector a. Vector a is 15 meters directed at 28 degrees. It has a positive component in the y direction. We'll label that AY. And a positive component in the x direction. We'll label that AX. So those are the two components that make up A. So let's figure out what they are. And we're going to use SOHCAHTOA to determine the components. So AY. So AY is opposite the angle. So opposite the angle, we're going to use the sine function, which says the sine of 28 degrees is going to be equal to AY divided by 15. So AY is equal to positive 7.0. Putting in a positive just to emphasize the positive direction. Now AX is adjacent to the angle, so we're going to use the cosine function. So that would be the cosine of 28 is equal to AX divided by 15. So AX is going to be equal to positive 13.2. And again, emphasizing the direction, AX is in the positive direction. Now C, I'm going to have to draw arrows, the component arrows for that. And we see that C is measured with respect to the x-axis, and the angle is 124. I could figure out what this angle here is. I'll call that alpha. But I'm going to figure out this one. I choose to do this one, theta. So I'm going to describe the components as follows, such that theta is within that triangle right there. So to figure out what theta is, I first have to figure out what alpha is. And alpha is going to be 180 minus 124. Well, that's 56. And then I know that theta plus alpha is equal to a 90-degree angle. So theta will be equal to 90 minus 56, which is 34 degrees in this case. So I'll use 34 degrees. That's right there. Theta is equal to 34 degrees. Okay, so now let's continue. So now I'm going to figure out what this is going to be CY and this is CX. So let's figure out CY first of all. So CY is adjacent to the angle. So adjacent to the angle, that's the cosine function. So cosine of 34 degrees is going to be equal to CY divided by 18, because the length of the vector is 18. So CY is equal to positive 14.9. It's positive because CY is pointing in the positive direction. Now CX. CX lies opposite theta. So that would be the sine function. So that would be sine of the angle 34 is equal to CX divided by 18. So CX is going to be equal to negative 10.1. So when I do the calculation, the calculator says positive, but I know that this vector is moving in the negative direction, so I need to add this negative in here. Okay, so don't forget that. Okay, so these are the components of these two vectors. So the next thing I want to show you is how to add the two vectors. Okay, so number 2. So what I suggest that you always do is take the information, the components, and set them up in a table just to organize your information. So we'll have 3 columns in the table. The first column will just list the vectors. So we have vector A and we have vector C, and this would be the x component and the y component. I'm going to take these numbers and just transfer them over. So we have positive 13.2 and positive 7.0, and we have negative 10.1 and positive 14.9. And here this will be the sum, sometimes symbolized with sigma. And if I add these, I end up getting plus 3.1 and plus 21.9. And these are the 2 values that describe the resulting vector. So when I take these 2 vectors and add them together, I'm going to get a new vector overall. And these are the components. So we're going to take in the x direction, that's 3.1, and in the y direction, this is going to be 21.9 positive. This isn't to scale, but it will give you the idea. And this is the resulting vector. We call that the resultant. Resultant. The result. Okay, and we have a theta in here that's bound by r in 3.1. We'll calculate that later. And the way I'm adding the vectors, you notice that I'm adding them tip to tail, the tip of one to the tail of the next one. That's how you add vectors, tip to tail. So this is called a tip to tail addition. That's the technique. So how do I figure out r? Well, I can use 21.9 squared plus 3.1 squared is equal to r squared. And that works out to r is equal to 22.1. I don't have any units here. Normally you would have units. To figure out theta, so what is theta? We can use SOHCAHTOA or TOA. What I'm going to use is I'm going to use the 2 components rather than relying on the value of r. So that would be TOA. So the tan of theta, which I want to figure out, is going to be equal to the opposite, which is 21.9, divided by 3.1. And theta works out to 81.9 degrees. Okay, so if we were to state what is the resultant of adding the vectors, we would say r is equal to 22.1 at 81.9 degrees, and this angle right here would be north of east. And the reason it's north of east is if we look at our coordinates right here, this is north, this is south, this is east, sorry, this is west, and this is east. So this angle here, 28, is measured at 28 degrees north of the east line. So it starts at the east line and moves north. This one here, this theta, would be 34 degrees west of the north line. So now let's do the third question, subtracting the vectors. So this is 3. And what we're doing is essentially we're doing this. We're taking and adding the vectors a plus a negative c. Okay, so we're still adding vectors, but we're going to reverse the direction of c. So the reversal of c is going to end up being opposite direction like that. Okay? And what that ends up doing is it ends up having that vector and that vector. Okay, so what we had originally is going to be in the opposite direction. So this would be cy and cx, and this would still be theta, and we continue from that point on. So what I'm going to do is just to clarify, let's set up a table again, x, y, and we have a and negative c. And we're going to add a to negative c. That will be our sum. A was reported to be positive 13.2 AX. AY is 7.0. And X, well, CX was 10.1, but now it's going to be negative 10.1. And before we had 14.9, so now we have negative 14.9 because it's the opposite direction. So if we take those numbers and add them up, we'll end up with positive 23.3 and negative 7.9. So these are the components of the resultant. Okay, so we set that up. We have, well, let me sketch it first of all. We have the x component, which is positive, and the y component, which is negative. So this puts this vector in quadrant 4, negative 7.9 and 23.3. And that's where I have my theta. My theta is always bound by the two vectors, in this case, the horizontal component and the hypotenuse. So now 23.3 squared plus negative 7.9 squared is equal to r squared. And do that calculation, and r works out to 21.9. And the angle again, we would have tan of theta is equal to opposite over adjacent, right? Which in this case, the opposite is going to be equal to cy divided by cx, which is equal to negative 7.9 over 23.3. So theta works out to negative 18.7. Now you may wonder, well, what does the negative mean? Well, all that means is that one of the vectors, one of the two vectors is negative. So the calculation works out negative. So you will end up getting a negative result if you have a vector in the fourth quadrant or in the second quadrant. It doesn't happen in the first and it doesn't happen in the third because both components are negative in the third, so the negatives would cancel each other out. So this negative right here, don't worry about it. Just report it as 18 degrees. Okay, now this is 18 degrees. The vector starts here and moves in that direction. Okay, the vector always starts, or this angle, not the vector, the angle always starts at one of the axes, the closest one. So this would be east of south.